Alright guys, today we're talking about lesson 10-7 or 10.7, which is discussing sectors and arc lengths. So if you watched the video on 10.6, we already kind of talked about what an arc is. We have not talked about what a sector is. So let's say we have a circle here. The concept we talked about yesterday, if we have the center, let's call it P, and I have a central angle here. Let's say it's 120 degrees. Okay, we can call, let's say this point up here is A, and this point here is B. We would call this arc that I'm highlighting in white, we would call that arc arc AB. Right? That's the minor arc, meaning it's less than 180, it's less than half the circle. That's arc AB. Well, there's a couple of questions they can ask you. They can ask you to, first of all, find the measure of arc AB, which again, we talked about this in 10.6. It's just the same thing as the central angle. So it equals the measure of angle APB, which is just 120 degrees. Right? But they can also ask you to find the arc length. Right? They can ask you to find the length. So this is the arc length, which is actually looking for, feet or miles or meters or the actual distance along this line here, right? So the actual distance of this arc here, not a line, of the arc. We're looking for that actual distance. So to do that, we have to use a little bit of logic here. Okay, so if my central angle is 120 degrees, I can ask you what portion of the circle that takes up, right? And the way to do that is to compare how many degrees we have, right? And the amount of degrees that we have here is 120 over the amount of degrees in the entire circle. And how many degrees are in an entire circle? Well, there's 360. So I know this is taking up 120 degrees out of the 360, which can simplify, divide both by 120. That simplifies to 1/3, which means this arc here, or this part of the circle, is actually 1/3 of the entire circle. It's a third of the entire circle because it simplifies to 1/3, right? So if I'm asking you to find the area of this sector, which is just that slice of pizza, if you will, it's just that slice of pizza. If I want you to find the area of this sector, I'm doing it yellow because the cheese on pizza is yellow, right? So imagine it's finding the cheese here. How much cheese do you need to fill up that slice of pizza? Well, it would just be 1/3 of the total area of my pizza, right? So if I know that the pizza has a certain area, and I'm looking to find the area of the yellow, then it would just be 1/3 of that area would just be the area of that slice, right? So the concept is as follows. If you're looking for the area of the sector, you take, how do we get the 1/3 again? Well, we took the central angle, right? So the measure of the central angle over how many degrees are there in a circle? 360. So that gives you the portion of the circle that is being occupied times, actually I'll go to another page here so that we can get more space here. So I'm going to go to this page. I'm going to place this right here. So again, we have the area of the sector is the measure of the central angle over 360. This is the portion of the circle that we're talking about, right? So this is just a portion of the circle times what? Well, if I'm looking for the area of the sector, you would do times the area of the circle, which is just what? Pi r squared. So what this represents is the area of the circle. So it's the portion of the circle times the area of the circle. Now, that some people get confused by that as to why that happens. Well, if I said that there were 10 soccer balls or something here, so that's 5, 6, 7, 8, 9, 10, and I asked you to grab 1/5 of those things, right? Well, you would multiply 1/5 times 10, which gives you 2, right? These 2 would be 1/5 of that, which is just, again, 1/5 times 10. So if you're looking for a certain portion of something, you need to multiply. So it's the portion that we have times the area, which gives us the area of that sector. So let's give an example here. If we have a circle and we know that the central angle here is 90 degrees and the radius is 12 meters. And I asked you to find the area of this sector. So find the area of that sector. Well, again, first of all, we need the area of the circle. So the area of the whole circle is pi r squared, and the radius is 12, so we get r squared, 12 squared, which is 144 pi square meters, right? So that's the whole area. Well, then what portion of the circle are we looking at? We're looking at a fourth of it, which a lot of you can see, common sense, it's a fourth of the circle. But how do we get a fourth of it? We do 90, because that's the central angle here, right? That's 90 degrees over the amount of degrees in a circle, which is 360, which simplifies to 1/4, but it's 90 over 360 times the area of the circle, which again is 1/4. The area of the circle is pi r squared, which we already said is 144 pi. So it's 1/4 times 144 pi, which should give you 36 pi, and again, square meters. Make sure you don't forget to put your units there. So 36 pi square meters. Okay? So that's kind of how that takes place. Now, you may be wondering, well, what if they ask you to find the rest of the circle? What if they ask you to find everything else? Do you have to repeat the process using an angle of 270 degrees here? And the answer is no, because if I know the whole circle is 144 pi, and the yellow part is 36 pi, well then the rest of it just needs to be 144 minus 36 pi, which gives you 108 pi, right? So you can just subtract the whole circle, which again is here, the whole circle, minus the, well that looks awful, minus the sector that we found, and that would give you the part that's left. Okay? So that's kind of the basics of how that would work. Now let's look at this concept of arc length. So we didn't really talk about that yet in detail. Again, I'm going to use the 120 analogy first. So again, this is 120. Let's say this is AB, and this is P. If they ask you to find the arc length of AB, well again, we need to realize that we're dealing with this angle here is a third. It's 120 over 360. It's still the same portion of that original circle, which simplifies to 1/3, right? So it's 1/3 of the circle. But now we're not worried about area. We're worried about the arc length. We're worried about this here. So we're not dealing with the area of the circle anymore. Hopefully you can remember the vocabulary word that represents the length of the outer part of the circle, which is the circumference. So we're looking not at 1/3 of the area, but now we're looking at 1/3 of the circumference. So how you do this is, again, you do the measure of the central angle over 360 times the circumference, which is what? 2 pi r. And again, this is the portion of the circle that we care about, or that we're asked to find. And this here is no longer the area, but now it is the circumference. Oops, ran out of room. Circumference. Okay, so let's look at a specific example here. So, if you have a circle, and it asks you, or it tells you that, let's go with this similar example we did last time. There's a 90-degree angle here. This is A, this is B, this is P. And it says to find the arc length AB, right? We're looking for the arc length AB, but all the information they give you, again, is that this is 12 meters. Well, what do we need to find? We don't care about the area anymore. All we care about is the circumference of the circle, because that is the thing that relates to the pizza crust, right? We don't care about the cheese anymore. We care about the pizza crust, which is the circumference. So again, we're going to deal with 90 over 360, because that's the portion of the circle we care about, 90 over 360, times the circumference, which is 2 pi r, right? But what is 2 pi r in this case? The circumference, c equals 2 pi r, oh, almost squared it, 2 pi r, which is what? 2 pi times the radius is 12, which gives you 24 pi. So in this case, to continue the work down here, we're going to have 1/4 of 24 pi, which is 6 pi. And again, the unit is meters, which means my answer here is meters. So we end up with 6 pi meters as the answer. Okay, so not too complicated of a lesson today. If you want to do more problems, I recommend you look in your textbook or any worksheets that if you're not in my class, that another teacher has given you, and see if there's a way to check your answers. So either doing like odd problems in your textbook, or looking at worksheets that have an answer key, or something along those lines. Okay, if you have questions, feel free to leave a comment, and I should get back to you by the end of the day. So anyway, thanks guys, appreciate it. Enjoy your day. Happy Geometry Days.